Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. From deep underground to high in the sky, these heavy metal marvels are essential to our daily lives. But what happens when these massive machines break down? Teams of mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet. Doing the vital repair work to keep these heavy metal wonders of industry alive. On this episode of Mega Mechanics, it's a multi-million-dollar balancing act at Hangar 3 for licensed aircraft maintenance engineer Stephen McDonald that requires brains, brawn, and nerves of steel.
It's got to come down.
One false move could see 6 tons of pure jet power come crashing down.
Hold it. Mark up.
Repairing worn bearings on a 550-ton excavator arm would hardly be considered a boring job for fitter and turner Paul Heiniger.
You can't speed that process up.
It takes over 24 hours of preparation to set up and just 30 very tense seconds to do the job and install the part.
These guys will be on standby with the rod in case it does get stuck.
There's no slacking off at the Rocky Point Sugar Mill as Brendan Smith and the team go into overdrive.
Nice and steady, mate.
Sparks fly during this bitter, sweet battle where danger must be managed.
But might be a lifesaver for one of the guys working in there.
For advanced mechanical tradesperson Steve Maybury, lengthy delays drag the chain as his team struggle to get vital equipment up to the worksite.
Not the best start to the day.
Under pressure and running behind schedule, replacing a large sliding door under a vibrating coal buffer bin has the team rigged and ready for action.
If something goes wrong, you've got a 1.5 ton door swinging at you.
On Australia's east coast in Brisbane, heavy maintenance aircraft hangar number 3 is a world-class facility. This aviation hub has a clear span of 160 metres and stands 8 stories high. 3 wide-bodied aircraft can park wing to wing, and this morning, it's a full house. A major job on the maintenance schedule today is an Airbus A330 that's in the hangar for an engine change. With 29 years in the aviation industry, the work is being overseen by licensed aircraft maintenance engineer Stephen McDonald.
So today we're removing number 1 engine from the aircraft for scheduled maintenance.
The GE CF6 engine weighs in at 6 tons. Removing the engine is a delicate job involving steel cables, pulleys, chains and lifting devices to manoeuvre the engine on and off the wing.
We obviously keep a good eye on them. Once they get to a certain point where our aeronautical engineers decide that it's time to remove it and send it back to the shop for its full overhaul.
On average, teams at this hangar remove engines twice a month. It's an intricate process that requires strict attention to detail.
Yep, cool. Happy with that?
We disconnect the various systems, the fuel system, the hydraulic system, the pneumatic system, the electrical system. There is a series of check-off lists that we go through.
To get the job underway requires the removal of the engine nose cowl. A custom stand designed to hold the 100-kilogram cowling is carefully guided under the wing and into position. Because of its size, overhead cranes are called into action to safely manoeuvre the nose cowl to the support stand.
Yeah, no worries.
It's got to come down just a little bit. Got about 1 inch to go. Steady. A little bit more.
Though they might weigh hundreds of kilograms, each part on this aircraft is treated with the utmost care and attention. With the nose cowl securely stored, next up the team prepare the bootstrap kit. This custom tool provided by Airbus is specifically designed to support the A330 engine during removal and installation.
That's it.
Like everything in aviation, it's a precise calculation.
Yeah, that's me.
Confident the engine is supported, the team carefully loosen the bolts. With an engine worth in excess of $10 million, you can never be too careful. Night has fallen by the time the team are ready for the large cradle that will carry this multi-million-dollar piece of engineering. As the crew take up the slack in the chains, it's a tense point in the manoeuvre. And Stephen is on hand to make sure this engine is handled with care.
Okay, John, if you just bring it up. Yep.
It's Stephen's responsibility to make sure this valuable piece of equipment is safely secured in the cradle without a hitch or a scratch, and all before the end of the shift. Near the small town of Oakey in outback Queensland, it's full production at the New Ackland coal mine. With temperatures often soaring above 40 degrees Celsius, conditions can be challenging. Every day, approximately 13,000 tonnes of clean coal is produced from this open-cut mine, thanks to the hard-working crews and the gigantic machines they operate. Keeping the site's fleet of metal monsters running smoothly is the highly skilled maintenance team. Many jobs are tackled here at the mine's workshop, but some assignments are just too massive, like this 550-tonne excavator. This beast can literally move mountains. Today, a huge 30-tonne bucket needs repair, so the maintenance team are called out to the mine's west pit to pay it a mechanical house call. Led by Assistant Supervisor Lindsay Bidgood.
Where the bucket attaches to the boom of the excavator, we're replacing the bearings in that and also line boring the stick.
The stick is the arm of the excavator where the massive 30-tonne bucket is attached. Stretched from wear, the joint has become loose and requires reboring.
I'll just keep checking this.
Yep.
Finish that and then I'll be with you.
At a busy mine, taking heavy equipment out of service puts additional pressure on the maintenance team.
The operation wants it back as soon as they can.
Making that happen will depend on two things: the weather and the condition of the shaft. Operating outside a workshop environment creates challenges for the precision equipment required to bore the hole to the exact diameter. Line boring is a process of welding the internal diameter of the bore using automated bore welding equipment, then using cutting tools held within a boring head to machine the size back to the required diameter. The first job is to clear out the old casings that line the shaft. These metal sleeves are known as bushes.
There, she's coming now.
It's no surprise the bushes are being stubborn. Their friction fit into place using liquid nitrogen. After a few sprays of lubricant and plenty of blows with a sledgehammer, another one's finally giving way. This work requires a significant amount of elbow grease. But it isn't the only job that has the maintenance crews working hard today. The crew back at the workshop are giving dozer number 612 a new track. Getting this workhorse back online is mechanical fitter Jonathan Lone.
So this is a D11R Caterpillar dozer. It's the biggest dozer that Caterpillar make. It's been utilised down in the pit for moving overburden last night, and on inspection they found that the left-hand track has a stretched link.
Dozer tracks work by generating ground hold and weight distribution, preventing the bulldozer from becoming stuck or slipping under huge forces. A stretched link is a sign that the tracks are wearing and could break.
If a chain breaks, then it's a major event. So we maintain and inspect these chains to ensure that they're serviceable.
The stretched link is considered a risk and a new track will be installed. With the 20-ton blade raised off the ground, the loader can start dragging the 6-ton track into position. It's a big job and requires a team of 3 people.
This is an expensive bit of gear, and the mine does depend on it to be serviceable and working, and they'll have an operator standing by ready to take over.
As the track snakes its way onto the rollers, the guys out at the West Pit are also making progress. But that's just a drop in the ocean of work still ahead for the excavator team. Just 50 kilometres south of Brisbane City is Yatala. And here, surrounded by a sea of sugarcane fields, is the Rocky Point Sugar Mill, which has been in production for more than 130 years. During the harvest season, known as the crush, this mill processes 4,000 tonnes of cane a day, resulting in 500 to 600 tonnes of raw sugar. After 6 months of round-the-clock punishment during the sugarcane harvest, the mill enters a period known as the slack. Despite the name, there's no slacking off during the off-season. Under the supervision of mill manager Bruce Tyson, the team are busy rebuilding the mill for the next harvest season.
We've got quite a few projects on the go this year, doing a lot of work on our milling train, replacing rollers, reshells. We're also doing a lot of work on pressure vessels around the evaporators.
There's just weeks to go before the first trucks will arrive with cane ready to be crushed, and there's a lot to get done. Today, hydraulic motors are being fitted onto these 12-ton rollers, and new vacuum pipes are being installed in one of the mill's gigantic mud filters.
We don't process it efficiently and wash the sugar out of the mud. With the mud filter, then our losses will go up.
This is the final chance the mill has to extract sugarcane juice from the crushing process. The mud filter is a horizontal rotating drum that is fed mud from juice settling tanks. Vacuum filters suck the mud onto a screen on the outside of the drum, which has a surface area totaling 64 square metres. Cane juice is vacuumed through filter screens and into pipes inside the drum. This leaves dirt and impurities caked on the outside of the drum, which are scraped off as it rotates. The mud filter is undergoing an upgrade, and new vacuum pipe work called manifolds have been designed in-house. Leading the installation crew is boilermaker Brendan Smith.
All the manifolds, once welded in, will have no air leaks. There'll be a complete vacuum seal, and that'll help extract the juice from the mud and back to filtrate.
Working in a confined space means only a small crew can do the job. But before Brendan and fellow boilermaker Dylan Ernst can head inside, their spotter, Krista Pootsman, needs to carry out her safety checks.
Paperwork's all done?
Yep.
Fantastic.
And I pump tested that thing, so you should be safe. Today the guys will be grinding, oxy-cutting and welding in a confined space, so that's considered as a high-risk work.
It's only Krista's second day working at Rocky Point. But with years of experience, she knows how important it is to be vigilant with safety procedures, like taking gas level readings.
0.
Okay.
CO level is 0.
Yes. And H2S?
H2S is 0.
This job is actually really important as it can save someone's life. And the oxygen level?
It's 20.8.
Yes, that is good. Then
Air quality needs to be regularly monitored to ensure the small space does not become an unsafe environment. But for now, the team has the all clear to start work.
Right, first things first, we're going to line these holes up.
It's like putting a puzzle together inside a dark cave. But it's a challenge these two are keen to take on.
Yeah, this is the first time we've done anything on this kind of scale with stainless steel. If we can, we definitely want to show our skill level.
Drilling holes through the mud filter's metal wall will be a challenge for the guys and the hole saw.
I'd love the drills to go through, for sure. It'll be a lot neater to weld, but yeah, it's a lot more effort to get the drill through 6mm stainless outside.
The drill's fighting, kicking back as the saw tries to bite into the metal. Spraying lubricant helps to reduce heat and prolong the integrity of the drill bit.
We're in for a long haul with these drill bits.
We're drilling on a slow speed to try and keep the stainless as cool as possible.
The team are trying to reduce the risk of heat fractures in the metal, but there's no assurance their plan will work effectively. It's a three-way battle, metal versus muscle.
How's she looking, mate?
We're not quite through yet, we're getting close though. There's one.
And that hole has taken them 10 minutes to cut. As they start hole number 2, the maths starts to sink in. 48 manifolds requiring 4 holes each means they'll have to cut 192 in total. At the rate they're going, it'll take 32 hours of hard slog.
Having a bit of dramas with the drill now.
How's the drill tips looking?
Well, they're looking all right.
The question is, will the hole saw last? And 13 minutes later,
Oh yeah.
the answer is yes.
2 of 192. 190 to go.
The guys swap over, and Dylan takes over the hole cutting.
How you going, mate?
Get there.
Or is he? 160 kilometres north of Sydney is the port city of Newcastle, the world's largest export shipping terminal. Each year, around 160 million tonnes of coal, mined from the Hunter Valley region, is exported to destinations around the globe. An integral part of the supply chain between the Hunter Valley coal mines and the world is Port Waratah Coal Services, which receives, stockpiles, blends and loads coal onto vessels for export. Ross Van Dyke is in charge of maintenance at Kooragang Terminal.
From a maintenance point of view, a large breakdown can have effect on the whole Hunter Valley coal chain. It's extremely important that we have maintenance support to make sure those vessels keep turning around.
Shiploading is the final link in the Hunter Valley coal chain. Each year, over 1,000 vessels are loaded in an operation that runs around the clock, 24 hours a day, every day of the year. When a shiploader stops loading to reposition between vessel hatches, coal travelling from the yards on the conveyor belt is redirected into a buffer bin. But today, there's a kink in the chain. A vibro feeder gate on a coal buffer bin requires urgent repair. The vibro feeder gate is the sliding gate at the base of the bin that opens and closes to control the flow rate of coal onto a conveyor to maintain a continuous shiploading operation. With a coal buffer bin out of service, the team will need to move quickly to repair the gate and keep shiploading operations on schedule. Advanced mechanical tradesperson Steve Mabry is up for the task, but it seems a vital piece of equipment required for the job needs some extra coaxing.
We're hitting the structure on the way up, so now we've got to jiggle things around a little bit, get it to come up.
An elevated work platform, also called an EWP, is required to access the job. Problem is, the vibro feeder gate the team need to repair is on the 3rd floor, and this EWP is reluctant to leave the ground floor.
It's just catching at the back near the chains. So hopefully you can lever it away and we'll be able to come up past that beam.
An elevated work platform is a piece of machinery that provides access for people and equipment to safely work at height. Generally, it's the EWP that does the lifting, but in this case, it's the EWP that requires lifting. Weighing in at 3 tonnes, it's not a simple manoeuvre to the 3rd floor.
I guess the longer that this takes to get up there, we start pushing back other people that need to get up there and build scaffold, and pushes our job back too. Not the best start to the day, but that happens.
Even though deadlines are looming, with this task the team have to proceed with caution. Constantly assessing the job, Steve has serious safety concerns.
Well, the risk is this heavy stuff falls, it could be pretty catastrophic. You kill people, do a lot of damage to machinery, so you've just got to stick to the rules and Do it safe. You ready?
The first attempt getting the EWP up and on the platform has failed, but the team are determined to succeed. Bring it down, re-rig the chains, and start the process again.
Right, that's Totsy.
It's time-consuming, but finally, after much trial and error, the EWP has negotiated the obstacles to reach the third floor work area. Now running hours behind schedule, the crew have a huge challenge to get back on track to meet shiploading deadlines. Keeping an Airbus weighing more than 180 tonnes cruising the skies are two GE CF6 jet engines. Here in Hangar 3 at Brisbane Airport, licensed aircraft maintenance engineer Stephen McDonald is leading a team tasked with replacing one of these multi-million-dollar engines. Aircraft checks are a form of routine maintenance, and the engineers have been notified this Airbus is scheduled for a new engine.
It entails a team of people to do that. We have 4 people on the lifting gear.
The team has meticulously disconnected the fuel system, hydraulics, pneumatics and electricals. They have the specialised lifting gear called a bootstrap in place and have dialed up the pressure to take the weight of the engine ready to come down into the cradle.
And then we'll do the other.
While this engine tips the scales at about 6,000 kilos, the weight is not distributed evenly, so it's not a simple lift.
There are different loads for the rear and different loads for the front. The front has a higher load than the rear.
Stephen gets the team to adjust the settings accordingly. It's a delicate balancing act that requires a great level of skill and experience. An overbalance would be catastrophic.
Can you wind that red dial down round to 2800 kilos, please? Okay, come down to the quarter fraction.
After double-checking weight conversions,
1260 kilos on the rear tugget.
with final checks and vital number crunching done, it's go time.
All right, gents, all together. Can we start raising it up, please?
To work in this kind of environment, technical expertise isn't the only skill required.
It's paramount to have a really good crew. You've got to be able to work together, good communication skills. Just stop on the back, only on the outboard front, please. Okay, up together, please. All 4. John, you go a little bit quicker. You get a good crew together, good communication skills, everyone's safe. It flicks over well. It's like clockwork. Safety is the big challenge. We've got to make sure that everything's done in a safe manner so there's no injuries to anybody. Okay, right, we're happy there. Okay, pins through, locks in, please.
A few minor adjustments, and
Okay, we're locked.
with lock pins engaged and the engine safely cradled, it's time to remove the engine bolts. Now safely suspended, the team are ready to lower the engine.
Let's come down together. Away we go. It's not a race to get it down. We get it down in a team and we just bring it down gently and carefully. And I say to the crew, if you see something that's not right, yell out stop. That's what we're here for.
The bootstrap kit has its work cut out, not only supporting the engine, but also the weight of the cradle plus the crew.
Down together.
Having a suspended load of this weight and cost is always a tense moment. The engine is down safely. The bootstrap kit and the team have been successful. Now to secure the engine ready to head off to its next destination.
Okay. So you want to take the load off so that we can disconnect the hooks, and we're going to put our pins in.
A tug is called in to take the engine to the workshop, where it will be completely overhauled. But this A330 cannot afford to stay grounded. A new engine is on standby to be installed immediately. So it's not time to put away that bootstrap kit yet. At the New Ackland coal mine in regional Queensland, the mercury is on the rise. Sweltering outback conditions make work mega challenging for the mechanics on the job. When a machine is too massive to come into the workshop, the maintenance crew head out to the pit. Standing at 8.5 metres tall, this gigantic digger has problems with bushes on the hinge joining the excavator's arm to the bucket. That's where fitter and turner Paul Heiniger comes in. With the old bushes cleared out of the shaft, he can set up the line boring equipment.
Basically what it does is just rotates the tool in the job. So pretty much opposite to what a lathe would do to a piece of metal. Instead of spinning the job, we're spinning the bar and the tool.
The first task is roughing out the internal diameter of the bore to remove gouge marks with his specialised line boring equipment. Working behind Paul, a boilermaker is gouging out bushes on the bucket. With sparks flying, it's like an industrial fireworks show. Next comes the welding phase, which adds new metal to the internal diameter of the bore.
We've machined out, so we'll fill it up back to 3 or 4 mil a side, and then that'll give us material to machine out to get back to size. It's a pretty long process.
While the job is progressing, working out in the open is causing problems.
This wind is playing havoc with our gas, so yeah, matter of trying to keep it going and keep the weld protected.
But wind could be the least of their worries.
We're a bit worried about the thunderstorms that could roll out this afternoon. We've been watching the forecast on the phone, and we just got to keep a close eye on it. And fingers crossed it doesn't rain, because that'll throw a spanner in the works.
Over in the mine workshop, things are clicking into place. Jonathan Lone is part of a 3-person team rolling a new track onto this 104-tonne dozer. It's a dangerous stage in the procedure, and with the risks involved, Jonathan's full attention is on the towing cable.
You could have, say, 20 to 30 tonne worth of straining force on that cable. So if it was to break, there would be significant damage to equipment and people as well if they're in the firing line of it. It's a job you have to take seriously and be careful with.
Jonathan can breathe a sigh of relief. Now the 6-tonne track is safely in place. Now to join the two ends.
It's a very heavy bit of equipment, so we need an operator on the forklift to raise the track.
It's a delicate job for such a heavy machine. A quick buff. Then they're ready for the master link. It's all moving along as planned, but the team are aware that at every turn there's a new challenge and safety issue that must be managed.
You're in a confined space working with heavy objects and other machinery as well, so it's always a little bit precarious.
With 15 years in the mining game, Jonathan is also well aware that time is ticking by, and this dozer needs to be back at work, earning its keep.
There's always a push for dozers. Dozers are frontline equipment, so they're needed at all times to be out there pushing dirt, clearing roads.
Using a hydraulic high-torque wrench to tension bolts is a task which must be executed with safety firmly in mind.
It's quite a dangerous device because there's multiple pinch points, and once again you're dealing with metal under extreme conditions and extreme forces, so you've got to be careful.
And with the track replaced, dozer number 612 is back in business. A short spin around the workshop compound, and it's all set to make tracks back to the pit. The Rocky Point Sugar Mill in southeast Queensland is in pieces, and in just 6 weeks it must be up and running for what will be a long and relentless sugar season. But a custom upgrade on some huge mud filters is not going according to plan for Boilermaker Brendan Smith and the team. Their plan A has come to a grinding halt, with a hole saw breaking after cutting just 2 holes. With 190 more holes to cut and hole saw bits costing $100 each, persevering with the drilling could quickly become an expensive and time-consuming venture. A call is put through to Maintenance Supervisor Terry Drury to discuss a Plan B.
We've got a decent sized centre pop in there, but it's still jumping around a lot, just with the curved edge.
Right, yeah. So you're going to plasma cut it?
Yeah.
Give it a go.
We'll give it a go.
I've got another cutter, but if you think you're going to keep breaking them, we won't do it. So give the plasma a go so you can get it neat enough.
Right.
The decision to use a plasma cutter means the holes will be made using electricity and pressurised air to cut through the steel.
Plan B, we're not going to get a perfect hole. I don't care how good we cut it, we're always going to have to use the die grinder to clean it up.
While the mud filter crew gear up to start using the plasma cutter, things are also heating up down on the ground floor, where fitter Brad Sampson is preparing a drive coupling to be installed onto the shaft of one of the mill's massive 12-ton rollers.
And we're just applying a little bit of heat to make it easier. It's a size fit, so both the output shaft and the input shaft are the same size. And we put a little bit of heat on the input shaft, grows a little bit, and it will slide straight on.
The coupling is interference fit, which means applying heat to expand the metal. Brad must closely monitor the precise temperature, or internal seals will be damaged if the heat exceeds 80 degrees Celsius.
There's a lot of heat up top, Harry.
While the heat torch does its work, Brad gets the overhead crane in motion. Manoeuvring 1.3 tonnes of bulky machinery into place takes an experienced hand on the controls.
I'm hoping this fit goes to plan, first try. Doesn't always happen. Right, put it down. Yep, come in.
It's a tense few moments.
Beauty. Home. That went well. That went really well.
And with that, the feed roller for number 4 mill is well on its way to be ready for the beginning of the crush. Whether it's a similar story with the mud filter up on level 1 will depend on how well Plan B using a plasma cutter goes.
It's still just a one-person job. It just means more ventilation into the confined space now because there is going to be a lot more fumes. Well done, man. Let's bring it down. Angle up.
More fumes means Krista's job as spotter has just become even more important.
Might seem like a little bit of unnecessary job, I'm just kind of sitting here, but might be a lifesaver for one of the guys working in there.
This may only be Krista's first week at the mill, but 4 years of industry experience has taught her the importance of safety. Today, the gas detector, or sniffer, is her most important tool.
And if that thing goes off, gives a signal, they will have to get out of the confined space straight away.
The first hole using the plasma cutter is complete. Now for the cleanup with a die grinder.
We've got our holes down to 2 minutes a hole, but with the extra 3-minute clean time and whatnot, we're probably on about the same as we were before.
2 minutes is a quick turnaround. And add to that working in a confined space that could quickly become unsafe. Will the team be able to get this mud filter back online in time for the crush? At Port Waratah Coal Services, raising an elevated work platform has been a challenging problem for Steve Maybury and his crew. Just getting vital equipment to the work area has already caused a lengthy delay. And at long last, with the EWP in place next to the coal buffer bin, the team can finally get to the job of removing the vibro bin gate. After several hours in the workshop for repair, the gate is trucked back to site for reinstallation.
It's fairly heavy. I think it's 1.6 tonne, they tell us. So some of the challenges is there's a lot of heavy lifting, a lot of chain blocking, fairly sweaty work. It can be quite dangerous.
It's never an easy task lifting heavy equipment. And while the EWP is in place, there are still hurdles to clear to get the door to where it needs to be. Every moment the job is delayed will also affect ship loading.
It slows up production. We can't get the coal on the ships as easily. With the buffer bins are an integral part of it, so we need them operating to get the flow properly.
Time is money, and while delays are always expected, it's up to Steve to get the problem solved sooner rather than later and ease the strain on other parts of the yard that have to juggle coal loading while the buffer bin is out of service.
We're constantly having operations asking, how long is it going to be, how long is it going to be, how long is it going to be? And they have to move trains around, they have to move shipping around, and it's a big headache for them.
Knowing they're already behind schedule, the team moves swiftly to raise the door into position. Working from the EWP, the 1.6-tonne door is lifted using the overhead crane. Chain blocks are attached to the front of the gate, raising the gate to line up with the slide rails.
So that door actually operates up and down to control the flow from the vibros.
Slowly, the gate is guided into position.
We've got a few brackets and things to put on. We'll take our locks off and give her a test run, see how we went.
The team worked quickly, aware they needed to do it safely.
If something goes wrong, you've got a 1.5 tonne door swinging at you, so you try to stay out the line of fire.
After the initial delays, the vibro gate door has gone in without a hitch and valuable time has been recovered. It's a credit to the skill and experience of the crew and the expert leadership of Steve Maybury.
The job's done. It'll come back in service okay. The end result is exactly what we're after, but it didn't go as smoothly as we planned.
It's a new workday for the heavy maintenance crew at Hangar Number 3 in Brisbane. The team can proudly hear the roar of the engines they've serviced as they take off from the nearby runways. One jet that is yet to roar into action is this new multi-million-dollar mechanical marvel. A CF6 jet engine, soon to get its moment in the clouds powering this enormous A330 aircraft.
So General Electric CF6 ADE1, it's thrust rated at around 72,000 pounds of thrust.
The huge thrust generated by the A330 engines are able to propel these planes that weigh 180 tonnes to top speeds of 913 kilometres an hour. They're amazing pieces of engineering and must be handled carefully. After removing an engine yesterday, licensed aircraft maintenance engineer Stephen McDonald has assembled a team to get this A330 one step closer to back in the sky. And everyone is aware of the challenge that lies ahead.
We have a very heavy engine, so the challenges are that we do it right and we make sure that there's no damage to the equipment or no injuries to anybody. That's probably the big challenge.
A specialised bootstrap tool provided by the aircraft manufacturer is integral in these engine installs to safely hold the jet's weight and keep it balanced when being moved. Working alongside Stephen is fellow licensed aircraft maintenance engineer Warren Lack.
So what we'll be doing, we'll be running the engine back in under. We'll then pull the pins and lift it.
Lifting 6 tonnes worth of engine takes a team of 5. One person on each chain or tugget, plus the leading hand calling the shots. Preparing for the lift is a complicated process with a long list of steps that must be followed. There's no margin for error. There are rigorous checks and balances to ensure the procedure is carefully completed. It's a job Stephen and Warren are well versed in, having carried out this task many times. The clattering of chains through the tuggets means it's almost time for this new jet engine to lift off. But the load must be checked again.
The majority of the weight's been carried by the front 2 chains. Their total load is around 2,800 kilos on each chain or tugget. The remainder is obviously on the rear. That's around the 1,200 to 1,300 kilo mark.
It's crucial to get these details right. Otherwise, this multi-million-dollar engine could come crashing down.
Okay, up together. Okay, Mo, just hold it.
Once it's raised, the transport pins are removed and the lift can recommence.
Lifting the engine can be a little bit tricky. There are certain angles you have to get it up so that the fan frame clears the thrust reversers.
Slowly but surely, this monstrous engine is guided into position. While they can't and won't rush a procedure like this, the clock is still ticking. Will this engine install be complete before the end of shift? At the New Auckland Open Cut coal mine, gigantic machines continually carve their way through the pit. But one of the fleet is powered down, having the linkage pin shaft on its 30-tonne bucket worked on. After 2 days of welding and boring, fitter and turner Paul Heiniger sizes up the team's work.
It's a millimetre too big. Have to start again.
Jokes aside, the difference or interference between the new bushes and the bores can only be 0.5 millimetre to ensure a precise fit. Once the grease lines are cleared and the line boring gear is removed, the real challenge can begin, using liquid nitrogen to shrink fit the bushes. And with this procedure, timing is everything.
Once we get it out of the liquid nitrogen, we've got about 30 seconds before that will position itself and expand. So it gets stuck.
To start the shrink fit process, the bore is heated up to 180 degrees Celsius, causing the metal to expand. While that's happening, the opposite scenario is in store for the new bushes. Liquid nitrogen at negative 196 degrees Celsius. A 10-minute bath in this freezing liquid will see the metal bushes contract, or basically shrink. Temperatures in the West Pit are up over the 40 degrees Celsius mark, and the liquid nitrogen is evaporating fast. Practice definitely makes perfect. Paul confidently sliding the frozen bush into the excavator arm.
Once you do it a few times, you know what to expect, and if it's not going to go, pull it back out.
Intense heat meeting intense cold sees a crust of frost forming on the bushes. Next, a spacer is put in place.
Stay there, Will. Let's see the heat coming through. Yeah.
Paul's got just enough time to make a few minor adjustments. As the metal bush returns to ambient temperature, expansion binds the parts tightly in place. The next one is frozen and ready to go.
Yeah, it's a quick process just getting those bushes in, that's for sure. You don't have a very big window. Yeah, as long as you're comfortable and don't panic, you're right. You just got to stay calm.
Cooler heads have definitely prevailed, with all of the bushes sliding in.
Yeah, but finished off and it's come up good. I think we've met deadline, so yeah, really happy with the way it turned out.
Handing over to the night shift, the bucket will be reattached with a linkage pin to the arm and be back in action in the pit 6 a.m. the following morning, ready to move mountains of dirt. Back at Rocky Point, the sugar mill is being overhauled, ready for the cane crushing season. Today, there's a small crew battling to install new vacuum manifolds inside one of the mill's 2 mud filters.
If we're only running on one, it will have a domino effect across the mill, either with reduced crushing rate or increased sugar losses into mud.
Cutting holes through the steel drum for the pipework is proving to be a major challenge.
Our first attempts at cutting some holes in the drum to fit the tube manifolds didn't go so well. We cut 2 holes and then we broke the hole saw. We now have to go on to plan B and we're going to use a plasma cutter.
While the plasma cutter is faster, the result is less precise and requires grinding the holes to size. But that's not the only hurdle the team has to face. Will the manifolds and the holes actually line up?
If the holes don't line up, then we'll be in plan C and we'll be remarking our holes and cutting them again.
Time to install the first manifold and find out.
Ready?
We're in. Yep. Happy, mate. Happy.
Dylan will use a TIG welder to tack the new pipes into place.
As long as we ensure that we've got a pretty round hole and our diameter's tight around our pipe, then it'll be a dream to weld.
The team have chosen TIG welding for this phase of the job. It creates less debris, makes a cleaner join, and all at a lower temperature.
Therefore, the heat transfer onto our stainless vessel will be minimal and we'll have no chance of a crack.
Finally, things are looking sweet for the mud filter team.
I feel like today's been an up and down day, but we've come away with a win with getting one of the manifolds in, and I'm pretty happy with how the day turned out. We're going to keep pushing forward and get the job done as quickly as we can.
It's an uphill battle to get the mill pieced together in time for the crush. And the mud filter will be ready to roll, thanks to the expert work of this team of mega mechanics. Aviation maintenance hangars like Brisbane's Hangar 3 run with meticulous precision. Teams of expert engineers maintaining, repairing, servicing billions of dollars of aircraft day in and day out. These workshops contain highly advanced technology and some of the largest aircraft in the skies. And keeping them up there are jet engines like the CF6 to be installed on this Airbus A330.
You want to square the engine up a little bit?
Warren Lack is directing the complicated lift of this new engine, which not only has to be perfectly aligned, but also raised on a specific angle for installation. It's a balancing act keeping this front-heavy engine in check. An error here would be devastating. The engine mounts are so close to making contact. But the closer they get, the more difficult the process becomes.
The last inch or so you take very, very gently to ensure that both the pin on the front mount and the pin on the rear mount go in together and actually engage comfortably.
One last adjustment.
Just go up slowly. There you go, it's in.
And this 6,000 kilo engine is perfectly aligned. Some final checks.
Okay, no gap there.
No gap here.
That's perfect. All right, gentlemen, well done. Let's get the bolts in.
The team have taken this difficult process and achieved a perfect outcome.
No real hiccups. As I say, just go gently. This is a job that you don't rush. You take your time, good communication skills, safety, bring it up together. Everyone talks and yeah, no, it went smooth.
With the jet engine now safely secured, the cradle is removed. Like unwrapping a present, this new jet engine is now one step closer to unleashing its power on the runway. With the lifting work completed, the next shift is set to reconnect the engine systems. The team are confident they'll see this new jet engine roaring to life and the A330 cruising the skies again, right on schedule.